So we're going to continue the 10.2 notes. This is section 10.2, day 2. Again, I have a PowerPoint we're going to go through for today, and this picks up in your packet of notes on page 9. We're going to start off by talking about this thing called the unit circle, and then that will lead us into the idea of a radian, which is another way to measure angles besides degrees. So the unit circle. The unit circle is a circle with a radius of 1 unit. That's kind of why we're calling it the unit circle. And we're going to note specific important angles around this unit circle. The first thing that I want to do is I want to just kind of note all the angles that are multiples of 30 degrees. So if this is my initial ray and it hasn't spun at all, well, that's just 0 degrees. If it's spun up to this first tick mark, that puts me at 30 degrees. To the second tick mark puts me at 60 degrees. The next one, 90. And really all we're doing is just adding 30 each time. We're just kind of highlighting these important angles. By the way, these are going to be particularly important in section 10.3 when we start applying trig to these things. And then definitely next year if you're taking pre-calculus. Continuing along, we have 120 degrees. We have 150 degrees. We have 180 degrees. 210 degrees. 240 degrees, 270 degrees, 300 degrees, and 330 degrees. And if we go all the way around, I'm just going to sort of relabel this angle over here as 360. 0 is if we haven't spun at all. 360 is if we spin all the way around. I'm now going to create a similar unit circle for angles that are multiples of 45 degrees. So initially, we haven't spun at all. That's 0 degrees. We spin up to this first tick mark, well, that's 45 degrees. Continue to vertical, you already know that that's 90 degrees. Continue to the next tick mark, 135 degrees, 180 degrees, 225 degrees, 270 degrees, 315 degrees, and all the way around is 360 degrees. Now, this was a good place to start, but usually the unit circle has these two circles combine into one. That's what you see on the bottom of page 9. If you haven't finished filling these in, please pause the video and make sure you fill in all those angles. But then what we're going to do is we're going to merge these two. And our complete full unit circle looks like what you're seeing now. This is what I'd like you to fill in on the bottom of page 9. All the important angles in terms of things we can do with trig. 0 degrees, 30 degrees, 45 degrees directly in the middle of quadrant 1, 60 degrees, 90 degrees, 120 degrees, 135 degrees, 150 degrees, 180 degrees, 210 degrees, 225 degrees, 240 degrees, 270 degrees, 300 degrees, 315 degrees, 330 degrees, and 360 degrees. What you will need to be able to do with these is you'll need to be able to basically take a blank copy of this unit circle, and if I ask you for a particular angle, know fairly quickly without having to do too much thinking where exactly that angle is. So if I say, for example, 210 degrees, you'll need to know that it's the ray that ends just short of, just below horizontal, just after 180 degrees. If you haven't filled in the entire circle, pause this video and fill those in. Otherwise, we're going to go on and start doing a little bit of locating. In the homework, it just tells you to put a dot where that angle is. Right now, I think I'm going to show the initial ray spinning, but in the homework, yeah, a dot will be just fine. 150 degrees, well, I know that that's the angle that's right over here, just before you get to 180 degrees. 150 would be that angle over there. 315, I know, is the angle in quadrant 4 that's directly in the middle over there. So spinning, it will look like this. Now, in terms of negative angles, I know that 30 degrees would involve spinning this initial ray to the mark that's just above the x-axis over here. That's 30 degrees. Negative 30 degrees is going to involve spinning the same amount just in the negative direction. Negative 30 degrees would put me over here. It would be coterminal with 330 degrees, by the way, but negative 30 degrees spinning this way and ending up over there. Do the same with negative 120. What I would do is figure out what positive 120 looks like, then just spin the same amount in the negative direction. So 120 would put you over here, negative 120, spinning to over there. Again, in the homework, you'll just be asked to put a dot on one of these blank unit circle templates where your particular angle happens to be. We now need to start talking about another way to measure angles other than degrees. And this method of measuring angles is called a radian. A radian is a way to measure angles like degrees, but it will relate the measure of an angle to the length of an arc along the circle that is traced out. Just copy this down. We'll figure out all the details in just a moment. A radian is a way to measure angles like degrees, and this method will relate the measure of an angle to how much of a circle is traced out, to specifically the length of the arc along the circle that is traced out. Do you need another moment to copy that definition down? Please pause the video. But let's start trying to. First thing, and all these things you should just sort of list as bullet points on the bottom of page 10. First thing, we are dealing with angles around what we call the unit circle. So it has a radius of 1. We know that one complete spin around the circle, 360 degrees, while using our new way of measuring angles relating to how much of the circle is traced out, well, if we go all the way around this circle, we're tracing out our entire circumference. I want an angle equal to the entire circumference. I have a formula for the circumference of a circle, 2 pi r. Again, this is the unit circle. My radius is 1. So if you go all the way around this circle, that 360 degrees, we're going to call that 2 pi radians. And this is all we're going to need to figure out every single other important angle around this circle. All the way around, though, is 2 pi radians. Now, if all the way around would be 2 pi radians, half the way around that circle would be, well, half of that. Half of 2 pi. Divide 2 pi by 2, and you're going to get pi radians. Haven't spun it all? That's 0. Spin halfway around the circle, we call that pi radians. Spin all the way around the circle, we call that 2 pi radians. Well, half a spin was pi. What about a quarter of a spin? Well, isn't a quarter of a spin just going to be half of this 180 degrees, just half of pi? Quarter spin must equal pi over 2 radians. I have 0, I have pi over 2, I have pi. 3/4 of a spin must equal, well, basically what I have to do is I have to do a half a spin and a quarter spin more. I know that a half spin is pi. I know that a quarter spin is pi over 2, so I'm going to say pi, plus pi over 2. Well, to add those, I need to get a common denominator, so I'm going to say pi over 2 plus, I'm going to turn pi into 2 pi over 2. I'm going to add those, and I'm going to get 3 pi over 2 radians. And these are probably the most important angles that we'll need to know around this unit circle in radians. 0 degrees is 0 radians. 90 degrees is pi over 2 radians. 180 degrees is pi radians. 270 degrees is 3 pi over 2 radians. And 360 degrees is 2 pi radians. And that was really our important factor that we needed to use to figure out everything else. What we're now going to do is move back into those unit circles that were multiples of 30 degrees and multiples of 45 degrees and figure out what each of those angles must be in terms of radians. I'm now in the notes. Our unit circle in terms of multiples of 30. Well, I know that 90 degrees is pi over 2. And I know that 30 degrees has to be a third of that. So I'm going to go find a third of pi over 2, 1/3 times pi over 2, and I'm going to get pi over 6. 30 degrees is pi over 6. It's actually going to be really easy to find all of the other angles now. I just need to add 30 degrees, or really pi over 6 to everything that I have. My next angle over here is pi over 6 plus pi over 6. That's just 2 pi over 6. My next angle over here, 2 pi over 6 plus pi over 6, 3 pi over 6. This is actually pretty easy. 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6. Well, hopefully you noticed, though, some of these fractions weren't reduced, and we really should go and reduce all of those fractions. So pi over 6 is okay. Pi over 6, I'm going to turn that into pi over 3. 3 pi over 6, well, I'll simplify that, divide the top and bottom by 3. It's pi over 2, which actually I already knew it was. 90 degrees is pi over 2 from our previous page. 4 pi over 6, divide the top and bottom by 2 to get 2 pi over 3. 5 pi over 6, you can't do anything to. 6 pi over 6, well, that's just pi, which again, I already knew. 7 pi over 6 is fine as is. 8 pi over 6, divide the top and bottom by 2 to get 4 pi over 3. 9 pi over 6, divide the top and bottom by 3 to get 3 pi over 2. 10 pi over 6 becomes 5 pi over 3. 11 pi over 6 you can't simplify, and 10 pi over 6, 2 pi. We will need to know these angles that are multiples of 30, and actually we're going to need to know the simplified versions. We're really going to need to know, and I realize this looks like kind of a lot of random numbers. I promise there are some shortcuts to kind of memorizing where these things are. I'll get to there in a little bit. Before I get to that, though, we need to look at this unit circle in terms of 45 degrees. I know that 90 degrees is pi over 2, and I know that 45 degrees has to be half of that. I'm going to go do half of pi over 2 to figure out that 45 degrees is pi over 4. I'll label that angle as pi over 4. Well, I'm now going to just do what I did with the 30-degree one. I'm just going to keep adding pi over 4 every time, and I'm going to label all my angles. Pi over 4 plus pi over 4 gives me 2 pi over 4, plus pi over 4 gives me 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Take a moment and simplify the fractions that you can simplify. Actually, they're good angles that we've already seen. Should be getting pi over 2 up top. Pi, where 180 degrees is. Straight down to 70 degrees is 3 pi over 2. All the way around is 2 pi. Again, we will need to know this unit circle in terms of the simplified version. Here's our simplified version of the 45-degree unit circle. Just like what we did with degrees, though, we're going to need to put these two circles. And I'm going to combine them. Please take a moment and fill in all of these angles on page 12 in your notes. Please pause the video and fill them all in. Then I'm going to give you some shortcuts for how to figure these things out very quickly. Please pause the video. You should have filled in on page 12, 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6, 2 pi. For things that we would have done if we were in class, and definitely for things next year if you're taking pre-calculus, this unit circle will need to be memorized. If we could start doing some of that work now, it's going to make your later work a lot easier if we can identify what angle is where. Again, my ultimate goal will be to give you a blank unit circle and ask you, find 2 pi over 3, find 7 pi over 6, things like that. I've got a bunch of tricks for memorizing these things, and this is what I want you to write in the notes on the bottom of page 12. There's a lot of blank space there. I'm going to first give you some hints for how to quickly figure out your denominators, and then some hints for how to figure out the numerators very quickly. And this is where we're going to end today. So a few hints. First of all, note that those angles that are closest to horizontal, right above horizontal, right above horizontal, right below horizontal, right below horizontal, all those angles are over 6. Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Make sure you're getting this in your notes. Next, what do you notice about the angles that are directly in the middle of each quadrant? 45 degrees, 135, 225, 315? You should be noticing that all those angles are over 4. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. All the angles right in the middle of a quadrant are over 4. Next, continuing along, if you look at the angles that are closest to vertical, pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3, well, those angles are all over 3. If we're closest to horizontal, those angles are over 6. Right in the middle, those angles are over 4. Closest to vertical, those angles are all over 3. So these hints will help you figure out what your denominator should be. If I point to a random angle over here, okay, this angle over here right below horizontal, I know it has to be over 6. But we still have to figure out a trick for the numerators. Tricks for those. As far as the numerators go, if we look in quadrant 1, all those angles have a numerator that's just 1 pi. I'm going to call it just 1, but pi, 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 pi over 6, pi over 4, pi over 3. Every angle in quadrant 1, the numerator is just 1 pi. Well, take a look at quadrant 2. I've got 2 pi over 3, 3 pi over 4, 5 pi over 6. What's the trick with the numerator there? How does it compare to the denominator if we ignore the pi part? Hopefully you're noticing in quadrant 2, the numerator, again ignoring the pi part, the numerator is 1 less than the denominator. 2 pi over 3, 3 pi over 4, 5 pi over 6. For all the quadrant 2 angles, the numerator is 1 less than the denominator. Quadrant 3. Take a look at those angles. 7 pi over 6, 5 pi over 4, 4 pi over 3. How does the numerator relate to the denominator? Well, 7, 6, 5, 4, 4, 3. Hopefully you're noticing in quadrant 3, the angles, the numerator is 1 more than the denominator. 7 pi over 6, 5 pi over 4, 4 pi over 3. Quadrant 1, numerator is just 1 pi. Quadrant 2, the numerator is 1 less than the denominator with a pi. Quadrant 3, the numerator is 1 more than the denominator with a pi. Continuing along to quadrant 4, these are a little bit tricky. How do we get 5 from 3, 7 from 4, 11 from 6? Well, for all the quadrant 4 angles, the numerator is 1 less than twice the denominator. What I mean by that is twice the denominator, 2 times 3 is 6, 1 less than that, 5. 2 times 4 is 8, 1 less than that is 7. 2 times 6 is 12, 1 less than that is 11. 5 pi over 3, 7 pi over 4, and my favorite angle, 11 pi over 6. Favorite angle because it's the only one with a double-digit numerator. 5 pi over 3, 7 pi over 4, 11 pi over 6. And the point is, hopefully, with these two tricks combined, you can locate any random angle. Okay, let's say I'm dealing with this angle down here, and let's say this unit circle wasn't labeled. I know this one is directly in the middle, so I know it has to be over 4. Well, I'm in quadrant 3, so the numerator has to be 1 more than the denominator. This one has to be 5 pi over 4, and things like that. You will need to basically be able to locate these angles around the unit circle. And if you're taking pre-calc next year, you will absolutely have to have this unit circle memorized. And if you start doing some of that now, it'll actually make some of our work in section 10.3 a little bit easier. Yeah, so again, if I give you just some random angle over here, let's take a look at this angle over here. I know it's quadrant, well, forget about the quadrant for right now. I know it's closest to vertical, so it has to be over 3. I'm in quadrant 4, where the numerator is 1 less than twice the denominator, so 5 pi over 3. All of our angles in the unit circle in radians, you will need to be able to locate all of these.